Cause and effect is the second cross-cutting concept in the K-12 framework for science education. This presentation will teach about the concept and how to integrate NAEP questions into the lessons to teach the cross-cutting concepts. Cause and effect boils down to what happened and what caused it to happen. Another way to say this is mechanism and explanation. Mechanism and explanation is defined as events have causes, sometimes simple and sometimes multifaceted, and a major activity of science is investigating and explaining causal relationships and the mechanisms by which they are mediated. Such mechanisms can then be tested across given contexts and used to predict and explain events in new contexts. Not only are scientists concerned with phenomena or effect, but they also work to understand the mechanism and relationship with the mechanism. Patterns provide evidence for phenomena and mechanism, or cause and effect. If something can be repeated, scientists start to ask questions regarding the scope of what happened and why. Repeating patterns in nature, or even events that occur together with regularity, are clues that scientists can use to start exploring causal or cause and effect relationships, which pervade all the disciplines of science and at all scales. The framework provides guidance for the goal of the cross-cutting concept cause and effect. One goal of instruction about cause and effect is to encourage students to see events in the world as having understandable causes, even when these causes are beyond human control. It boils down to understanding relationships and supporting them with adequate evidence. The National Assessment of Educational Progress, or NAEP, is used around the country to determine how schools are doing compared to other schools in particular content areas. It also includes online testing. NAEP released practice questions for teachers can be used as they see fit. NAEP questions are useful to use in lessons and assessments to help students get comfortable with the format and learn strategies to advance their own learning. The Next Generation Science Standards, which use the K-12 framework as a guide, developed a concept progression for different grades. They align some content standards or core ideas with the cross-cutting concepts. This is one example, but there are many more cause and effect relationships that can be found within the K-12 framework core ideas. In this chart, in K2, students learn that events have causes that generate observable patterns. They design simple tests to gather evidence to support or refute their own ideas about causes. The performance expectation states, plan and conduct an investigation to determine the effect of placing an object made with different materials in the path of a beam of light. The first grade physical science standard deals with different materials in front of a beam of light. This is a good opportunity for students to investigate with flashlights and lamps. Have the students make notes of the patterns first, then have them put the patterns into words. Finally, have them use the pattern to determine a cause and effect statement. Why would a person be cooler on a hot sunny day in a light colored t-shirt and shorts than in a dark colored t-shirt and shorts made of the same material? We've identified two possible grade band endpoints, one for physical science and another for earth and space science. So how could you use this question? 3 examples include a class discussion, inquiry project, or science writing or sketching exercise. Questions that you might ask would engage, first of all, student background knowledge. So have you ever experienced this? Can you imagine what this might feel like? What would you choose to wear on a hot day? Why? Why is it hot on a sunny day? What does the sun have to do with it? What time of year do we have most of our hot sunny days? What differences would you feel wearing a dark shirt and shorts versus a light shirt and shorts? And finally, can you help design an experiment in which we could test some of our ideas? Cause and effect relationships, or lessons, are great opportunities to incorporate written statements. Students might complete a written response such as, if blank, then blank. The following question is another example of cause and effect. To keep a heavy box sliding across a carpeted floor at constant speed, a person must continually exert a force on the box. This force is used primarily to overcome which of the following forces? The options are as follows. A. Air resistance. B. The weight of the box. C. The frictional force exerted by the floor on the box. D. The gravitational force exerted by the earth on the box. The grade band endpoint refers to pushes and pulls instead of forces. Teachers will need to introduce scientific terms to students if they have not done so previously. This question could be used as a research theme for a unit on forces. For instance, the goal could be, keep the box moving at a constant speed on the carpet. The teacher then could ask the students to consider what is keeping the box on the carpet, since it's just sitting there, and to remind them that it's a heavy box. This would also be a good chance to introduce friction to students. The students could then experiment with sliding things on carpeted and non-carpeted surfaces. The teacher could ask, which is easier to keep something moving smoothly? And how can our experiment help us answer the original question? The teacher could then ask students to develop cause and effect statements or if-then statements. The last example we'll provide for the K2 grade band is as follows. Gerald, standing at one end of a room, rings a bell. Lena, standing at the other end of the same room, hears essentially the same sound as Gerald. A. What causes the sound made by the bell? B. How does the sound travel across the room to Lena's ears? The grade band endpoint for second grade addresses waves, vibrations through matter, and sound. The question provides more opportunity for students to design experiments to test their ideas. This could also address some of the science and engineering practices. Some questions the teacher might ask would be, what makes sound? How do you know? And how can sound get from one place to another? And then have students develop cause and effect statements or if-then statements after performing or designing an experiment. NGSS developed one example of how to pair the cross-cutting concepts cause and effect with a core idea for grades 3 through 5. There are many more pairs educators may identify within their curriculum. Cause and effect in grades 3 through 5 encourages students to begin testing causal relationships. Identify relationships that reoccur regularly and form a pattern or relationship. The first example of the grade band 3-5 is as follows. The diagram above shows a cross-section of two river valleys. In each diagram, the river is represented by the shaded region. Which river valley is in its more mature stage of development? What two features in the diagrams make you think so? The NAEP river question requires a constructive response to answer both questions. To get students thinking about the question, a teacher might ask, where does the water come from to get to the river? What might the path of the water be like? Where have you seen rivers shaped like either of these diagrams? The teacher could then follow up those questions with the following. How does water change the shape of the landscape as it flows over the earth? Some possible experimentations would be with earth materials and water, as well as an examination of Google Earth or landform resources. While experimenting, the teacher could ask, how does a river's shape change over time? She could also, or he could also, ask if the water flowed for a shorter amount of time, what would the river look like? If the water flowed for a longer amount of time, what would the river look like? And how does that compare with the two pictures we have? The 3 to 5 grade band endpoint also addresses multiple forces acting on an object and how it impacts the movement of an object. The question reads, Kelly slides a flat rock across the smooth ice of a frozen pond. The rock slows down after several seconds. What causes a rock to slow down? A. The thickness of the ice. B. The temperature of the air above the ice. C. The force of friction between the ice and the rock. Or D. The gravitational force between the ice and the rock. As students read this question, they have to think about, what are the multiple forces that could be acting on the rock as it slides across the frozen pond? In this question, it's important that students understand what is the effect or the end result that we're most concerned about in this question. And in this question, we're concerned about that the rock is actually slowing down. So A. We are also not concerned with the direction of the rock, but only that it slows down. A question that's important for students to think about would be, what are some forces that we already know that slow down objects? They also need to think about what happened to the rock and why did it happen? And then what is the relationship between the force and the fact that the rock slows down? The final question we're going to address in the 3 to 5 grade band is the following. A city block of land will be developed into a park with a playground. The soil on this site is contaminated to a depth of 18 centimeters with lead, which is harmful to humans and other organisms. The lead must be reduced to safe levels before the land is developed. 3 methods of removing lead from the soil are described in the table below. All of the treatment methods described will successfully reduce lead to safe levels. Each method has environmental advantages and disadvantages. In the table below, identify one environmental advantage and one disadvantage specific to each method. Cause and effect deals with relationships between what happens and why it happened. Students are required to look beyond the possible methods in this question and look into the future. What could happen next? If this happens, why did it happen? What different relationships can we find within the 3 proposed methods of cleaning up the soil? Cross-cutting concept cause and effect begins to introduce multiple variables in middle school science. Phenomena may happen for a variety of causes, and sometimes they may not happen at all. Data sets become much larger, and scientists must take into consideration larger systems to understand cause and effect. NGSS identified at least one performance expectation that coincides with cross-cutting concept cause and effect, but many more exist. The identified physical science standard addresses developing a model to explain and predict how matter changes as temperature changes. The first question we'll look at in the 6 to 8 grade band is bacteria cause and effect. A scientist studied the growth rate of a species of bacterium. The scientists introduced some of the bacteria into a flask of nutrient-rich solution and monitored the growth of bacterial population by measuring the number of living cells in the solution. The graph below shows the growth of the bacterial population over time in hours. Explain why the growth rate of the bacteria changed as it did during the following time periods. Refer to the data and your understanding of cellular processes and their regulation by internal and external environments. These time periods are between hours 6 and 12 and between hours 16 and 24. First, students must identify the phenomena, what's happening to the population of bacteria during the 2 time periods. After identifying the phenomena, they can then start looking for a cause. Why might this have happened? What do we already know about population growth and the needs of cells that might relate to the relationship we see here? We must also be critical of the experiment to make sure it is valid. If we could perform any tests, what would we want to do? What do you want to know more about in order to determine the cause of the population change? Lastly, how can we turn this into a cause and effect statement? What is the cause and what was the effect? What happened and why? This will be the last question we address in the 6 to 8 grade band. The picture below shows a rock formation with folded layers. Which statement best explains how the rock layers folded? A. The rock melted and flowed downhill. B. The rock was deformed by a meteorite impact. C. The rock was suddenly pulled apart during an earthquake. Or D. The rock was slowly compressed due to tectonic plate movement. Middle School Standard ESS 2B covers plate tectonics and discusses that it provides a framework for understanding Earth's geologic history. Students need a background in basic geology and plate tectonics. Students need to start by looking at the phenomena. What are we looking at? What happened? The rocks moved and bent. What do we know about this process? Is it a slow process or a fast process? Looking at the picture, what tells you about the time scale of the event? Based on the provided answers, which one fits best with your possible time scale? Develop a cause and effect statement. The rocks folded because blank. NGSS has released suggested cause and effect concept progression. High school incorporates empirical evidence to specify between cause and correlation. How clear is the relationship? Additionally, consider scale in cause and effect relationships. Does the relationship still exist if we change the scale of the phenomena? The first question in the 9 to 12 grade band is as follows. Some people have proposed that ethyl alcohol, or ethanol, which can be produced from corn, should be used in automobiles as a substitute for gasoline. Discuss 2 environmental impacts that could result from substituting ethyl alcohol for gasoline. Students need to be able to address the difference between renewable and non-renewable resources. Is corn a renewable or non-renewable resource? What might be needed to produce ethanol? What is an environmental impact? Environmental impacts can be both positive and negative. If using ethanol is the effect, or the cause, what are the environmental effects? What will happen to the environment because of using ethanol instead of gasoline? Craters of the moon. The surface of the moon is covered with craters, as shown above. How were most of these craters formed? A. By eruptions of active volcanoes. B. By impacts of many meteoroids. C. By shifting rock on the moon's surface, moonquakes. D. By tidal forces caused by Earth and the Sun. It's important for students to ask, have I seen this shape before? Could it be recreated in a lab? What would you need to do so? Is any testing or research needed to support the relationship between the cause and the effect? Which answer or cause most likely aligns with the phenomena? The last question we'll address in the 9 through 12 grade band is as follows. A newspaper article reported that a fossil was found that was 200,000 years old, according to generally accepted radioactive dating procedures. A letter to the editor of the newspaper disputed the accuracy of the age determination because the fossil was found closer to the Earth's surface than were previously discovered fossils of the same age. Which of the following would be an appropriate argument against the letter writer's claim? A. Older rock layers commonly lie deeper underground than younger ones. B. Older rock layers may be pushed closer to the surface by geologic processes. C. The age of a rock layer can often help in determining the age of the fossils it contains. Or D. Fossils form only under certain conditions. The goal of this question is to refute the letter to the editor with an appropriate argument. What best addresses the letter writer's claim that the depth of the rock is the reason to question the age of the rock? What could cause an older rock to be near the surface? Does this happen enough to be considered a regular phenomena? What is the cause and what is the effect in this geologic relationship? How could you state it clearly in a response letter? For more information on the cross-cutting concept, cause and effect, view the first article link and the second video link by Paul Anderson, a science teacher in Montana.